Lithium is a mineral, and it's in our phones and laptops, but it's also all over the place in nature. It's found in seawater and in rocks, as well as in brine wells. As a result of the increasing popularity of lithium ion batteries, the demand for lithium has skyrocketed. In fact, lithium is now the most sought after metal on Earth. As the demand for lithium increases, so do the effects on the environment. Lithium extraction fields in South America have been captured by an aerial photographer in stunning high definition. But while the images may be breathtaking to look at, they represent the dark side of our swiftly electrifying world. Lithium represents a route out of our reliance on fossil fuel production. As the lightest known metal on the planet, it's now widely used in electric devices, from mobile phones and laptops to cars and aircrafts. Lithium-ion batteries are most famous for powering electric vehicles, which are set to account for up to 60% of new car sales by 2030. The battery of a Tesla Model S, for example, uses around 12 kilograms of lithium. These batteries are the key to lightweight, rechargeable power. As it stands, demand for lithium is unprecedented, and many say it is crucial in order to transition to renewables. However, this doesn't come without a cost. Mining the chemical element can be harmful to the environment. The vivid hues of the lithium fields or ponds are caused by different concentrations of lithium carbonate. Their colors can range from a pinky white to a turquoise to a highly concentrated canary yellow. A 2015 piece in The New Scientist described the fields as surreal landscapes where batteries are born. But why is lithium extraction bad for the environment in the first place? Any type of resource extraction is harmful to the planet. This is because removing these raw materials can result in soil degradation, water shortages, biodiversity loss, damage to ecosystem functions, and an increase in global warming. But when we think of extraction, we think of fossil fuels like coal and gas. Unfortunately, lithium also falls under the same umbrella, despite paving the way for an electric future. Lithium can be described as the non-renewable mineral that makes renewable energy possible, often touted as the next oil. Lithium is a highly toxic element that can harm the environment. It's poisonous to plants and animals, so when it's released as part of mining activities, there will be an impact on the surrounding area. Lithium can affect water bodies by turning them into toxic wastelands. They become unusable for humans or other living things because they're poisoned by lithium. This can happen through direct contact with these bodies of water, or through indirect contact if you eat food grown in these areas. Lithium affects soil composition and structure. This makes it more difficult for plants to grow in this area because they don't have adequate nutrients or minerals available for them to produce healthy root systems. The air becomes polluted as well, since there's more dust being kicked up from all those trucks driving around digging up rocks. In addition, the environment around these mines can become very polluted. Lithium is known to be highly toxic in large doses, and the mining process involves drilling holes into the ground while pumping water out of them. This can result in toxic wastewater being released into local streams, rivers, and lakes, and this water may not be cleaned up properly before it's released back into the wild. According to a report by Friends of the Earth, lithium extraction inevitably harms the soil and causes air contamination. As demand rises, the mining impacts are increasingly affecting communities where this harmful extraction takes place, jeopardizing their access to water. The salt flats in South America where lithium is found are in arid territories. In these places, access to water is key for the local communities and their livelihoods, as well as the local flora and fauna. In Chile's Atacama salt flats, mining consumes, contaminates, and diverts scarce water resources away from local communities. The production of lithium through evaporation ponds uses a lot of water, around 21 million liters per day. Approximately 2.2 million liters of water is needed to produce 1 ton of lithium. The extraction of lithium has caused water-related conflicts with different communities, such as the community of Tacanao in the north of Chile. The extraction of lithium from brines requires pumping them out, evaporating them, and leaving behind a solid brine cake that must be disposed of. Lithium extraction requires a lot of water. To extract 1 ton of lithium, you need approximately 500,000 gallons of water. Studies have shown that mining takes up approximately 65% of water in Salar de Atacama, Chile. The high water requirement puts a halt to farming activities in many parts of the world. Perhaps this might mean mining the metals makes little economic sense, but depletes the environment. In one of the most common lithium extraction methods, the producers pump up brine from the underground pools. They then allow the sun to concentrate the mixture in the evaporation pool. The miners then add sodium carbonate and calcium carbonate to precipitate lithium carbonate and lithium hydroxide. The brine must lose as much as 95% of the used gallons of water for the precipitation process to begin. From the extraction process analysis, you can see that lithium extraction allows too much water to evaporate. Because of inadequate water supply, lithium extraction causes an acute water shortage in most arid and semi-arid mining areas. So it can promote the prevalence of waterborne diseases like dysentery and cholera. A common threat among the world's lithium mining areas is in dry, hot, and mountainous regions. In 2018, Australia, Chile, China, and Argentina were the world's largest lithium mining nations. That has changed little in 2022, as we've seen. Lithium mining also denies trees with shallow root systems the opportunity to make their food and be productive. The pumping will contaminate the environment with dissolved salts, while evaporation of brines produces large volumes of wastewater that must be treated before they can be discharged into surface or groundwaters. In addition to being toxic for marine organisms and plants, lithium brine wastes can also contain other compounds such as magnesium bromide and calcium chloride. These compounds are toxic in high concentrations and will cause severe damage if released into the environment. It's estimated that more than 100 million tons of solid waste are generated every year by mining operations in Australia alone. This means that approximately 4% per annum of all materials extracted during this process ends up as waste material, which must then be disposed safely or recycled. So, should we stop extracting lithium for batteries? Probably not. Lithium is a very useful element in the world of technology and has a huge number of applications. It's used in many different types of batteries, including those that power our phones, laptops, and electric vehicles. However, we need to ensure that we are extracting lithium from mines that have been designed and built with safety in mind. We also need to make sure that all the waste material from these mines is properly contained and disposed of. Tesla succeeded, creating a narrative around battery technology which the rest of the private sector is likely to try and emulate. The building of momentum around batteries raises the question, what do we do when the market demands millions of batteries at once without any plans for their second life? To avoid the disastrous situation of them ending up as hazardous waste, the cost of recycling or repurposing lithium needs to be optimized. For example, batteries from EVs could be recycled and used in smaller appliances, drastically increasing the battery's life cycle. A report published in 2021 also identifies water as a primary concern for lithium mining operations. It claims that not enough research has been done on the potential contamination of water, and activity must be stopped until studies are available to reliably determine the magnitude of the damage. Researchers like Yushin are working on new battery alternatives that would replace lithium and cobalt, which is another harmful metal, with less toxic and more easily accessible materials. As reserves of lithium and cobalt will not meet future demand, suggested elements to focus on instead are iron and silicon. Unlike lithium-ion batteries, iron flow batteries are also cheaper to manufacture. We call on material scientists, engineers, and funding agencies to prioritize the research and development of electrodes based on abundant elements. Otherwise, the rollout of electric cars will stall within a decade. Well, that's it from this video. What do you think of the environmental impact of lithium? Do you think lithium mining should be restricted for the sake of a sustainable future? Share your thoughts by commenting below. If you enjoyed this video, hit like and share this video with your friends to help spread awareness. Also, consider subscribing to our channel for more interesting videos every week.